Yes, this might get into aliens. That is okay.
Yeah, I've got some insights.
What?
This week on the RCN Recap Podcast, Cutter Shea
Gotcha. Yeah. Why would you leave this dream job, Cutter?
joins Ellis in studio.
Cutter. Mr. Cutter Shea, welcome. What remains your most prized lesson?
Man. Yeah, give me a minute here.
Mr. Cutter Shea, welcome to the Recap Podcast. You were recapped in issue number 40, I do believe, which recounted the 2016-2017 story of NASA's OSIRIS-REx spacecraft and the abundance of technologies and engineering that accompanied it. You happened to catch the RCN LinkedIn post about it. We talked very briefly, and here you are in Boise. We're going to talk at length about current ongoings and focuses as it regards to your role at Cintoo today. But I'd like to start with what OSIRIS-REx's purpose was, and then we're going to do a bunch of reverse engineering from that. And additionally, we're going to mention why the craft is still making headlines today, but we will get there. So OSIRIS-REx, what and why?
All right. Well, first, Ellis, thank you very much for having me.
Pleasure.
From what I could understand is scientists had identified an asteroid that is old. Really old, and kind of from the beginnings of the universe. Mm-hmm. And it also, they said that it hadn't been damaged in any way. So I'm not sure what that means, but it could have clues to, the origins of the universe, clues to the origins of stars and planets, and possible clues to life. So NASA thought it'd be a good idea to let's get a sample from it and send out a satellite. So that's kind of what I understood as my low job as an engineer, but high aspirations.
Certainly. So there's this identification, this hypothesis, I guess, as it were. You were not with NASA at the time. You were with a separate company.
Correct. A very small aerospace startup called Avior out of Longmont, Colorado. But sure enough, from time to time, the phone would ring and the caller ID would say, like, NASA Johnson Space Center. So we were a small aerospace company who would make motors and gearboxes for larger companies, NASA being one of them.
Okay, so motors and gearboxes. So that being your focus with Avior, was that something you had delved into prior? Was it something you picked up, you found the position with Avior, and then you developed a passion and a skill set for motors and gearboxes? How did that coalesce into this role in working with?
So always had a passion for science fiction movies and science fiction writing, and naturally that led to just a general interest in rockets and satellites. And graduating with a mechanical engineering degree, I was applying for all these sorts of jobs, and one of them was a small aerospace startup company from my hometown. And luckily enough, I was the third engineer, but the second engineer who was hired, his wife was my counselor at university, so that's how I got the job as the third engineer for the small aerospace startup. And I wouldn't say that motors and gearboxes are my direct passion, but as soon as you put those on a rocket or a satellite, you have my full attention.
Certainly. So day one, phone call one from the fine folks of NASA. What happens? What can you recall about the recruitment, as it were? I mean, was there already an existing relationship between this company?
So our direct client was actually Arizona State University, and the initial relationship was through the founder, Scott Starren at Avior, and his entire career he'd worked at Ball Aerospace and another aerospace company. So he'd made some connections in the industry. He'd also he'd used those connections to win contracts for NASA, Arizona State, and other aerospace programs. So it was kind of the founder, his career in aerospace, and Arizona State giving us a call.
Tremendous. So zooming out, you mentioned maybe motors and gearboxes are not your number one passion in life. That's fine. But something led you to this position with a background in engineering, right? Your background in degree,
correct,
I do believe, are in engineering.
Yep.
So what were some of the pivotal moments that took you from campus to Avior?
Good question. Um, Wonder. Being just really turned on to the wonder of science and the magic of science. And I can remember on campus, uh, the first time that I got to use the scanning electron microscope, and I got to zoom in to incredible levels of magnification on this walnut leaf. I remember that. That was kind of one of those first moments of wow and wonder. And I'm no longer in high school. I'm not mixing vinegar and baking soda to make a volcano. I'm using the most high-end microscopes on the planet. And that wonder and drive pushed me to, like, maybe I could work on satellites and rockets. And the drive was there, and the dream and the passion was there, and you kind of have to fight for it and want it, and meet the right people, and then prove that you got the stuff. And I can remember that moment, that scanning electron microscope giving me some wonder and motivation to push, to try and be an aerospace engineer.
Seeing things differently, quite literally. I mean, through this,
Good one.
hyperspeed microscope, incredible. So, part of the reason this whole recap, number 40, came about was that it was about Lockheed Martin, I believe, and digital twinning. And they basically, to enable that from their perspective, which again, we're talking about a decade ago, it was still a pretty audacious feat. And it was through something called model-based systems engineering. Now, by chance, is that something to which you could speak? Is that something that you at least are privy to, or what that was with the twinning effect? Because they were able to simulate basically what they wanted to do in this mission.
Yes,
through this.
I can speak to it, not to the great depths and details.
I understood.
But, so this is also kind of where we hit a fork in the road, and because this is the reality capture network, we're used to digital twins that are like buildings and such, and we're used to models that are not physical, but like when I say I've got a model of a building, oh, that looks like a building. This model-based systems engineering, the systems would include the solar panel systems, the battery systems, and some of the propulsion systems of the rocket or satellite. And when those get modeled in a computer, it's quite literally what you see on the screen is just a box, and the box says solar panel array. And it simulates all the inputs. So if it gets really complicated, as in, so if the solar panel array is facing the sun at a 50-degree angle for 50 seconds while we're rotating at such a rotational rate, how much input wattage are we going to get? But that's also dependent if we go behind a planet and we're in shade for a long time now.
Okay.
So it's a lot of the inputs that go into a very complicated kind of box in this system. Then those outputs would be wattage that goes to the battery system. So this model is quite literally just really complicated Lego pieces that feed a cycle. And they let these NASA engineers know, are we going to have enough battery power 1 million miles away? Are we not going to have enough? Also, they're simulating protecting a lot of the sensitive sensors from radioactivity and what's it called? Just harmful stuff from the sun. So it's simulating the path. It's simulating the energy inputs in, the energy inputs out. And it's a lot of systems engineering for mechanical engineers, and it's not like we've got a building that we're looking at for a model. However, I do want to talk about the model that they do create, that we do know for the satellite. So that's systems-based engineering at the most shallow level, kind of.
I'll be darned. So let's just pick up on it. I mean, if you want to talk about, so they created an actual model of, you're saying the satellite itself?
Yes. And then this is kind of where I get to touch into level of detail.
Yes.
So the level of detail was a concept that was introduced to me in AEC. But me coming from the mechanical engineering world, I'd only known every single detail of every single part always gets put on there.
Yeah.
So in AEC, LO, level of detail 1, this building is just a cube block. And then you can add windows and doors for a level of detail 200. The modeling that I was doing at Avior and the modeling that Arizona State and Lockheed Martin are doing for this satellite, every individual screw has a thread pattern. And it's not just a fine pitch or a regular pitch thread pattern. It's the exact thread pattern. Every screw and bolt has Phillips head or flat head inside of it. Each one of those bolts has the material that it's made of, its yield strength test, its tensile strength. So I'd only ever known the highest level of detail in every single part to be made into these models. So modeling is a universal word, and it was used in many different parts of this program.
On a macro level, because again, we're talking about a decade ago, was there a zeal and enthusiasm about what this could be? I mean, maybe it wasn't brand new at the time, but it was certainly far less, I think we can say, accepted, embraced than it is now. This notion, I mean, to me, as someone fairly new to the industry, the fact that this was ongoing then is remarkable. Was it something that ignited excitement because of how people assumed it was going to be exploding in popularity, or was it almost a cool kids club? Like, look what we get to do, and
it's a bit of both. So I got excited because I was a junior engineer.
Yeah.
Scott Starren, our founder, I can always remember this. He said that aerospace is not an industry for an impatient man, because we started our designs in 2014. We assembled it in 2015, shipped it off. The rocket didn't launch for another year and a half until 2016. Didn't touch down until on Bennu for years. But it's a waiting man's game. And I didn't feel any of that excitement from the senior engineers. I think it's because they'd done similar stuff like that before.
Yeah.
But inside, I was just a cheerleader, waking up every morning. I get to go to work, rah, rah, rah.
Yeah.
I get to work on satellites. This is going to an asteroid.
Yeah.
So I think it's more of an experience thing, junior engineer versus senior engineer.
Yeah.
And also just how long you have to wait for results. No one launching the rocket is cool. Returning with the sample is what is causing the celebration now. So,
yes.
So yeah.
I literally, within weeks, I think, latest updates being suspicion that, I think to your initial point in this conversation, that this thing may damn well carry at least hints about something regarding life or the beginning of the universe. When you mentioned the name, we should clarify. So Bennu is the name of the asteroid?
Correct.
Is that right?
Yep. Bennu.
Bennu.
Bennu is what I've been calling it.
Bennu. That end. Yeah. 4.5 million or billion years old? It's
Probably
up there.
billion.
Yeah. Astounding. And so the mission, I think, initially took 2 years, something like that, to retrieve the samples. And then you're talking that trip back, and then it's still, and analysts are still sifting through it. I mean, it's remarkable at what this was able to do. When you talk about legacy, a legacy project, my goodness. So one of the things, now I knew Arizona State rang a bell, and the reason was photo coming across. You, in all your humility, have not mentioned this yet. Your signature is riveted to the side of the now wait, let's do a little one-on-one. So satellite is a part of the craft itself? Is it some ancillary, or is this what are we looking at here, Cutter? What are we seeing right here?
So this is a small metal plate with the signatures of all the people who had helped on the Arizona State part of the mission, which was at the top, the thermal emission spectrometer. So all of the engineers, all the machinists, all the assemblers, everyone who was deemed a significant part, we got to write our signature on some paper, send it in. They then, let's say there were 100 people, they made 101 copies, took that extra copy, riveted it to the side of the satellite, and then sent out all the rest to the people who had helped. So you had made the newsletter talking about this. I made the comment. Now it's like, here's my signature. That's really cool to see that echoes of my past career are coming forward.
and I'd be lying were I to say that it's not something that is a gratifying part of this newsletter development, and taking a very objective approach to highlighting just the rad people that proliferate this industry. And then stories like this come up out of pure, as a quinky dink, and look what happened. So what a story. So we had this being riveted on as best as you can return to that day when this thing launches. What is going through your mind? And I still want to get to some testing with these gearboxes and motors and dig into there a little bit. But what is going through your mind when this thing takes off?
I think it was happening in spring of 2016 because, I can remember it was a nice day out, but I also remember, oh my gosh, this is going to be webcast. I remember I blocked out the calendar on my on Outlook, and I had my laptop computer open. I think I was streaming NASA or whoever was showing it, and I had a little one-person party at home. I even threw my hands up in the air when the rocket took off, and you better believe I was remembering launching Estes rockets with my father when I was in like 4th or 5th grade, and just a lot of pride in the work that I'd done, a lot of pride in what this is going to do, and a lot of the emotions kind of like I said, wonder and motivation of what's in space and working with the state-of-the-art technology. And it was kind of a culmination of my efforts, even at a young age. So it felt really great.
Beautiful.
Seeing that rocket go up.
Beautiful. Cannot imagine. We've touched on engineering, modeling. Let's grab some wrenches. Can you just give a high level again? Just service is fine.
Yeah.
A 101 motors, gearboxes as they pertain to spacecraft. How they may differ from other vehicles, shuttles, whatnot. And I know that's many moons ago for you.
Yep. Let's see here. So fundamentally, the electric motor is the same. However, the standards that we build to and the tolerances that we build to are extreme.
Yeah.
One of the jokes is that all the raw metal and all the raw parts that we start with, they have to come with certification. Boy, were we always tracking certification. And the joke we were saying is that every single part of the motor, you can trace back to the exact cave that it came out at, the exact mine, the exact day that the raw material came out. So traceability is everything. And then the tolerances that we were working with. So when we were getting two parts to fit together, our average tolerance was plus or minus 0.005 of an inch. So things fit really tight. And no, I can't say what the loose tolerances of, say, some Chinese motors are today, but none of the backlash. Everything fits tight. We've tested everything when it comes in, so that would be quality assurance, and then we test everything when it goes out, quality control. So I did mention the plus or minus, 0.005 of an inch. On our even tighter fitting pieces, it was plus or minus 0.005 of an inch. So I can't even hold my fingers up to show how tight that is.
Yeah.
But tight tolerances.
You need your microscope. Back in
Traceability.
school.
I need that scanning electron microscope. My goodness. So, and rigorous testing afterwards. So when we say it's going to do something, we guarantee it with paperwork and about a few hundred hours of engineering testing. Goodness. So but at the same time, it was kind of the same pieces of, not the same pieces, but conceptually still the same thing as a cheap motor. Just when money doesn't matter, you can throw that out. You just go, you engineer to the highest of tolerances.
Absolutely. Yeah. Strive for perfection. Any memories, stories, accomplishments, feats, collaborations with any other names in this lovely photo? Do we have Scott? What was this gentleman? Scott Starren?
Yeah, Scott Starren. So my signature is circled there in red, and two above that would be Scott Starren.
Yeah.
And so he was absolutely a mentor of mine, a serious engineering mentor. He started his career, I believe, with the Hubble Space Telescope.
Okay.
And yes, landing a spacecraft on Bennu is probably the coolest thing I've ever done. But Scott Starin was a project manager for the James Webb Space Telescope that I don't know if it's functional yet, but I think it's been in orbit now, and it's supposed to make the Hubble telescope look like a disposable camera. So he's a big player, and he's the most important person I've worked with on that plate. So
tremendous. So JWST, yeah, I do. I know there's been. It's certainly in orbit. I feel like I've seen images of some deliverables from that old boy, JWST, but yeah, I think the excitement is still, it's not even reached its near potential yet.
Mm-hmm. But these are all teams from across the country, different universities, different machine shops, and we all kind of work in our silos, but we all have these mission directors who kind of pass down the workload and the chores and make sure everything gets done so all the individual units can work as a team.
Can you address, so we've got, the origin story for this was a Lockheed simulation and basically the grounds for digital twin. We have ASU here, Avior, obviously NASA. The interdisciplinary collaboration, were there egos involved? Is this something that were there, I don't want to say headbutting, but almost with this many cooks in the kitchen? Did it ever get messy? And just...
Yes.
Okay.
It doesn't happen often, and it's not like on a TV sitcom or anything, well, at least I didn't see anyone throwing any mugs or tossing any papers in any meetings, but there are CDRs, critical design reviews, and we were on a different one with Lockheed Martin, and we were getting grilled. We're not in trouble here, but they're just asking the most difficult questions of the most difficult details, and then there kind of comes an impasse on when, we're the client, this is what we need, when, well, we're the manufacturer, this is what we can provide. We did come to a engineering agreement, but it got a little hot, and egos got involved because these are people who think they're the smartest person in the room, and then they get in a room with the other smartest people in the room, and it got a little hot in the room, but thankfully no fisticuffs or throwing.
Sure. But it is understandable, It's not just the sheer aptitude of so many people, but you think about the gravity of pardon that pun, but of this project, of course, and it's almost, you mentioned in CDRs, but that's almost an expected reflection of how you were talking about tolerances, right? With that sort of precision, it's not surprising, but I just got to think with that abundance of brilliant minds, different factions, different roles, and probably different desires and approaches and philosophies, it could be contentious at times. I would expect nothing less. Really, really insightful. So we talked motors, gearboxes. If we can hang on, and we're going to get to modern day, don't you worry, by the way, because there's going to be some real full circle stuff. Environment and designing and testing in an environment that you can't test in directly. Deep space, surface of an asteroid. And we touched on simulation, again, the preface to digital twinning, but how? How do you account for that? How are you able to study where it's going to be and on what surfaces, and then how it's going to react to the craft and environmental factors?
Another great question. We had to do external third-party testing for vibration testing, which simulates the rocket launch. We had to do third-party testing for vacuum testing. So I believe it's a hyperbaric chamber. We didn't have the money to buy our own, so that was also third-party. But the one test that we got to run in-house and that I got to program, which was kind of cool, was the cryogenic chamber.
Oh, boy.
And I never took a class on cryogenic chambers. We didn't have that at Colorado State University.
But they did put Dr. Evil in it, I think, at the end of Austin Powers.
Well, yes, they did.
That was my first.
Did.
Yes, let the record show.
But I read the directions. I was able to program 48-hour cycling between -40 Celsius and I believe Yeah, negative 40 Celsius up to like 20 Celsius for 24 hours. So those are the extreme tests that I can remember. Cryogenic in-house, vibration testing to simulate rocket launching externally, and then the hyperbaric chamber. And the vibe testing was pretty cool because we had some spot in Longmont, took it to this lab, and it was a metal table similar to this size, but on just some massive motors. And just when you'd see it shake and rumble, it was pretty extreme. I think 20, 30 Gs, maybe a 40 G peak. So we would just bolt down our motor and shake it.
Yeah.
But that's how you simulate space as best you can.
That is absolutely wild. So space simulation, I mean, what would you say is a common, to get back to just the roots in engineering approach, I mean, a common misconception people might have about engineering for space?
Awesome. We do not use titanium because it's lightweight. Everyone comes in, they're like, oh, you send stuff into space, right? Must be made of titanium, huh? Zero stuff is made of titanium because it has really bad thermal properties and thermal expansion and contraction. So obviously weight is critical. They'll tell you, I think it's used to be $20,000 per pound to send something to space. Yeah, they're bringing the cost down. Obviously weight is important, but once you're up there, the cold when you're in the shade is extreme, and you'll get contraction. And then as soon as you get out of the shadow and into the sun, it can get really hot in space. So you get a lot of expansion. High quality stainless steel in everything. It's very heavy, it's very strong, and it has great thermal properties. So that was the biggest misconception that I got from people outside of aerospace once I started working inside of it.
Forget those people. I would have supplied the same one as a theory. Is there a cause as to what, was it a movie that sort of engineered this belief that titanium was basically ubiquitous in, because I've heard it, and I certainly would have assumed.
No,
I wonder where it stemmed from.
Titanium, well, people who heard of it, I remember titanium got popular in the 90s because of golf clubs, and it was lightweight and it was stronger. But
it also has a great ring to it. It sounds very sophisticated.
It does. It is a sharper name.
Titanium. It's like the engineering equivalent of, you can just attribute a quote to Mark Twain, and it just sounds about right. Yeah. If you just say titanium can do something or is optimal in a certain setting, the people are like, okay, yeah, they'll just nod their head, like they'll accept it. Like, yeah, Mark Twain said that.
Oh, if you want to joke about metals, unobtainium, that's a lot of jokes about unobtainium.
That is excellent.
But that was the funny and clear misconception that I got from a lot of people.
Yeah.
It needs to be lightweight, right? Well, yes, but
just not even less than people would think, but just zero, by and large, no titanium because of its thermal, we'll call sensitivity.
Yeah, expansion and contraction.
Certainly. Yeah, those are motifs, and one of the sections of this newsletter is the AEC Air of the Week, and that thermal angle, as someone, again, only a few years into this industry, but I was not privy to at all about thermal, we'll say, problems that can arise in just certain environments and unpredictability, therein. Anti-titanium. Tremendous. So you've had your hands in numerous technologies and trades, even preceding this and certainly after it, which we're going to delve into deeper. But a couple clinging questions to just space and space travel. I mean, what would you say among them all is going to be most integral to continued space development, potentially even colonization?
Gotcha.
You can say craft. I mean, you're a drone maestro. That's fine. I mean, modeling, engineering.
I think it needs to be a general excitement with the public, and we need to see kids being excited about space, and we need to see teenagers and adults talking about space. And I wasn't alive during the summer of '69, but the space race and Kennedy and those Saturn V rockets, and there's kind of this sense that people coast to coast in the United States loved NASA and were excited about space, and it's kind of the cultural zeitgeist of the moment. And I think that's what's needed is public push and a public excitement, because then the government would possibly fund more of it. So, and yeah, the people will demand more of it. So, make spaceflight cool again.
That's very astute. Any personal theories? No right or wrong answer as to why it waned as it did.
It's easy to make fun
Just
of
say
nerds.
cell phones.
You know,
Just say people look
Oh.
down. Do the old cell phone rant. I mean, I joke, but maybe it's not. I mean,
We stopped sending people to space in the
Yeah.
90s as well. Like
Yeah.
it ended up being purely robots, and the Sojourner Truth robot was really cool. I believe that was Mars, or yeah, probably not the moon. But I think that might be a big part of it, is when astronauts stopped going into space, then there's less of that human touch, less of human connection for people on the ground.
uber insightful. And I'm now thinking okay, not to enter Debbie Downer mode, but and I was barely born at the time. But if we go back to the Challenger, I want to say off the top of my head 88, 89, 90, somewhere around there. But I mean, could that have had an effect on human?
I'd have to say yes, because wasn't that one of the most publicized ones pre-launch, where children in all of the schools coast to coast were watching live? Like they took time out from their regular school days to watch Sally Ride go up, and that it had to have
Never thought about that, but
left a bad taste in a lot of people's mouths.
And the ripple effect of you've got, Richard Feynman led inquiries into, I think, what happened, and that sustained for months, if not years, if I recall. Probably treading out of my water here, but I know Feynman, I think, helmed the committee that, looked into something with the O-rings, what caused the failure, Yeah, I've never thought about that, but that being an impetus toward this reduction in human-included space travel, yeah, that's very interesting. But I think that's spot on with what you're saying to reignite that passion.
Space travel and being an astronaut also really lends itself to trust. I can't think right now of anything where you're more trusting of the government, of the scientists, of the program leaders to bring you back safely. Because yes, there is a head pilot on these human missions, but not the pilot in the sense of they're grabbing joysticks in the rocket anyway and taking someone up and back. It's a lot of this relinquishing of control, relinquishing of your power, trusting that you'll come home safe. And when these accidents happen, some of that trust probably erodes with the public and maybe some of the astronauts. Just because they joke, they're sending me up in a metal can. So it only takes one bad metal can for some people to possibly drop out.
Wow. Yeah, it's like a Chernobyl effect, like for nuclear, like energy, it's just we can really fixate when things do go awry. Trust. You may have just answered what was my next question, but I'll pose it regardless. What remains your most prized lesson from just your entire OSIRIS experience?
Ooh. It was the recognition. It was the plate, and then not only that, sharing that with my father. I think I had a dinner at home that weekend, so I had these given to me at work during that week. And I knew, I was like, I have to show this to my dad. So later on, when I went home to my parents' house for dinner, hey, Dad, I've been working on some satellites and stuff. Told him the story about how it's riveted to the side of the satellite. This is my copy. And I cried a little when I showed my dad my aerospace, my space accomplishments. So all the alien movies that we'd watched, all the times that he'd answered my little 5-year-old questions. Well, why is the sun so hot? Like, where do comets come from? And like that was the culmination of showing my sci-fi dad that we sci-fi did it. Yep, that was cool.
Absolutely beautiful. Wow. Yeah, if that is not an indelible moment, I do not know what is. That's outstanding. OSIRIS launches. Job plus or minus done. the ignited passion for reality capture, reality data, laser scanning, drones? What prompted?
Gotcha. Yeah. Why would you leave this dream job, Cutter? Why would you leave this job that is so exciting and fills you with wonder? A large part of mechanical engineering and a large part of aerospace are defense contracts and defense companies and working and making parts for rockets that, other rockets. So it would be the summer of 2015, I had some personal issues that were taking up some mental space. I had, and then these contracts coming in for other companies, defense contracts, and working on different types of rockets, taking up some mental space. I wasn't in a good headspace for that, and ended up seeing a job posting for a sales engineer just by chance. And I thought to myself, I didn't even know sales engineering was a thing. You're either a civil engineer, you're a mechanical engineer. But wait, I always gave the presentations for the group. I always loved I could always talk about engineering. I think I should check this out. So it was a sales engineer position for Faro Technologies. I don't know what that is, but I like talking about technology. So did some interviews, took some phone calls, and had a final interview with Matt Daly, who you may have met, or has come through this office before, but he hired me in to be a sales engineer at Faro Technologies, working with laser scanners, which was completely new concept and technology to me. But I love tech. I love using it, and presenting and talking about it is really fun for me as well. So this was actually the position I was kind of born for, talking about technology, translating technology, and educating. So that's how I got into reality capture and laser scanning, was kind of this transition from aerospace into a more fun and interactive sharing of technology.
You say translating, educating. You weren't even a rookie at this point. You were a complete greenhorn with laser scanning, and yet Matt Daly saw something. What do you think it was that allowed him to take this chance on someone for whom laser scanning was an unknown entity, right? I mean, you had you're obviously savvy, college graduate, like you had bona fides, albeit very different ones, but he saw something. I mean, for you to take, first off, were you yourself even nervous? I mean, the passion was there, but it's something that was completely in the dark, and you find yourself in this position. Matt sees something. What do you think it was?
I think it's my ability to connect with people, and it's my ability to empathize with people. I believe that if I can hear someone's story, hear their problems, not their personal ones, their problems at work,
Certainly.
that I can try to truly understand what's happening with them and truly help their problems, build rapport, build a relationship, but also have that technical knowledge and technical experience on the back end. So the sales is this delicate dance, and technical sales is a delicate dance with big words. So I kind of was able to dance with Matt Daly and talk the talk while walk the walk, and it's a rare combination of skills, especially for engineers. So let's see here. It's kind of easier to teach an engineer how to public speak instead of taking a public speaker and teaching them engineering.
Okay.
So I think it's the blending of those two skills.
Absolutely. So with your rich background in sales, what would you say is harder, appealing to boardroom execs or field workers?
In my experience, they are equally challenging for different reasons. The boardroom executives, they always want the ROI and what's the value proposition. But then the field workers, they oftentimes they look at the they look at the fancy new machinery and they go, well, that's going to break, or well, that's not going to work in the mud. So I've got to use a whole different terminology. I've got to I have to prove it, but in two different ways. So it's kind of like, is climbing Mount Everest tough? Well, yeah, I've got to climb two different ways. It's not just one path to Mount Everest. It's two different paths, and I got to be able to climb them both. So they both offer their own challenges, but I'd say at the end of the day, I like working with the field workers and putting on my boots more than I like putting on a collared shirt. So
Certainly. Back to these early days here at Faro. Okay, we have let's make the trio persuasion, education, and technical knowledge. Okay, what was the steepest learning curve? So being able to educate people. Now, of course, the technical knowledge would preempt that, and then persuasion, just that gift of gab. And what was the steepest learning curve coming out of Avior?
The steepest learning curve was just the technical knowledge of laser scanning.
Okay.
It stands on its own. The terminology, the language, there was nothing like it in school that I had talked about. There was nothing like it in aerospace. So point distances and time of flight and registration and workflows, these were all new words for me. So I started at zero. Thankfully, I was given free. I was given my scanner and all the time in the day to just scan 100 of scans a day.
Excellent.
I made all the mistakes.
Yep.
Learned from those mistakes. But after about 6 months, I finally knew what I was talking about, and I wasn't just repeating things I'd memorized. And then the education became easier, and then the convincing became easier as well once I understood what laser scanning and registration was all about.
A positive domino effect, essentially, coming from that.
But I saw zero transferable skills from mechanical engineering education or aerospace into laser scanning.
Yeah.
Well, not transferable skills, but transferable concepts and like ideas. Yeah. Engineering concepts, and talking about like planes and angles and technical stuff was good, but laser scanning is its own beast.
Yes. Do you recall your first point cloud you laid eyes on?
I don't.
Oh.
No. But I do remember the first thing that I got to scan on my own, though.
Okay. Hit us with it.
So I'd just gotten back from Orlando. Faro is headquartered in Orlando. I just got back to Denver. I've got this brand new scanner, and you know what I'm going to scan? And it's what everyone always ends up scanning. You see on LinkedIn.
Hold on, the horse at the airport.
Oh, I wish. No, that is very illegal ground to walk upon. But I scanned the Denver skate park, and everyone who ends up getting the scanner ends up scanning the skate park in their cities.
Yep.
And I can remember showing, I'll go early. It's at like 8 a.m. to avoid the skateboarders. Well, there's still some skateboarders there, but they were interested in what it was doing. I'm kind of moving around the skate park, and it was early in the morning, long shadows, new tech. Looking back on it, I had horrible scan positions.
Of course.
My settings were completely wrong.
Yeah.
But I was so happy to have this new toy, expensive new toy, and I'm going to take it to the skate park. So, yep.
Yeah.
That was the first one that I made myself without any help.
Absolutely. In looking back, would you say, even though, hindsight's 20/20, things were just off and they're not ideal, but at the time, how aware were you of the micro failure, and did you even allow it to bother you? Or were you just embracing I have this new toy, I'm going to just keep striving? Or were the moments of discouragement, essentially, in this continued trajectory of learning and becoming a practitioner?
Mistakes are discouraging, but I'd always learned from my mistakes.
Yeah.
And then they say that it's only a mistake if you repeat it. And I kind of love just getting my hands on the tool or making those mistakes, because I know that that's how I learn best, because each mistake is branded so strongly in my mind. Like, I don't want to do that again. So once I figure it out, it's fairly certain that I'm blah. I rarely repeat mistakes because the first time I do it, I said I remember it forever. Don't want to do that again. So I'm very eager to go out and kind of, I don't want to break stuff, but when I'm new, I'm not afraid of making those mistakes because that's my best learning process.
The next chapter after Pharaoh. What and why?
So Pharaoh was about 5 years. A colleague of mine at Pharaoh had been recruited by a large engineering firm to start a scanning company. He was more of a sales guy, so he had a great network and could talk the talk. But he had some challenges, and he needed someone who could be the technical lead for a team. So he tapped me, "Hey, Cutter, do you want to come join this large engineering firm and start up a scanning company?" I had kind of gotten tired of traveling, 2 to 3 weeks out of the month, and this was an opportunity to work hybrid in an office. I'd sold scanners. I'd seen people doing the service. I've probably had 100,000 scans under my belt at that point, so it felt like a great progression to start a scan team, provide the service, and start to learn those lessons of having people underneath me and needing to sell and market. So Kimley Horn, that was the next company, Kimley Horn.
And safe to say, you had years at Pharaoh. At this juncture, you're not lacking confidence in terms of your just reality capture scanning prowess.
Correct. I was on top of the world. In 2018, there was the ASCC, the American Society of Concrete Contractors. They kind of held a study. They got maybe a dozen laser scanners from different manufacturers, different workers to get together. And it was to see who could be the most accurate on this raised concrete platform. And even though it was a study, not a competition, I won. So I felt on top of the world for scanning, very confident in my abilities, and giving the best point cloud with the least error.
Salute, sir. Your affinity for drones. When does this enter the picture?
2016, I believe.
Okay.
The company was called 3DR. They had reached out to Pharaoh and see if we could do some collaboration. So myself and Matt Daly, we went to their offices in Berkeley, California. Got to watch them fly a drone and take a lot of pictures. And you're telling me these pictures can then turn into a 3D point cloud? Okay, more of this magic science stuff, but I'll believe you. So it was a collaboration with Pharaoh and 3DR. I got my first drone, but this is also the time that DJI had started to enter the market.
Okay.
And 3DR quickly had to pivot from being a hardware manufacturer to software. So that's getting down the road a little farther, but it was a 3DR collaboration with Pharaoh that got me started with drones.
Okay. I'm actually just curious, as you can best recall, with DJI's entry, I mean, was it just a price point that they were able to, at that point, were they dominant out of the gate with?
No, it wasn't out of the gate. It was iteration number 2.
Okay.
Because 3DR, an American-based company, they, I believe, they had a good drone for out the gate. So they ordered, I believe, I'll call it 20 million drones.
Yeah.
But we all know that technology evolves, technology changes, things get better. So I think just as soon as their 1 million drones gets delivered, DJI just comes out with just something that's slightly better. And because they're in China, they're closer to the manufacturing. They're like their design office and manufacturing office are probably just down the road from each other.
Yeah.
So in 6 months, when DJI came out with their second drone, it was already just slightly better, and then another 6 months, slightly better, and the iteration period and frequency was so much more rapid.
Yeah. Pretty revolutionary. So you say 2016. This fire began with drones, and we're talking again in a time frame time, right? It's almost a decade. In these years, what evolution between just strictly laser scanning and drones has impressed you more? What has evolved on the whole more impressively?
I am more impressed by drones. Not to say that laser scanning hasn't, but the advancement is greater in my eyes. So the drones themselves are flying longer and flying faster. But in my eyes, the drone is just a flying tripod. So it's what instrument or sensors you put on it. The cameras are getting better. They're starting to use laser scanners now from these drones. So, like I said, the flying tripod, lots of advancements, but people are putting better sensors, better cameras, and then the software and the processing software as well is the critical key. Because if you've got pictures and you've got laser scanning initial data, it still has to be processed.
Yep.
So these the technologies are advancing, and because the drone is so much more mobile, the results and the projects are that much greater.
Yeah, certainly. So Cutter, having worked in both, I mean, you're checking boxes in aerospace and AEC. What are some surprising similarities and differences you've observed in how each industry approaches innovation?
Yep, there's this classic, there's got to be a name for it, but this kind of new technology curve, or this new technology kind of excitement and acceptance. So both well, now that I'm saying this, aerospace, I take that back. Aerospace and construction are very different. Construction is always trying to adopt new technology. It is a little resistant, but laser scanning and the mobile cameras and mobile scanning, GPS, these are all technologies that have been introduced and are working deeper into construction. And even though there's a little bit of resistance, technology is making its headwinds. Aerospace, it's kind of a paradox because yes, the Hubble telescope was the wildest thing in the 80s and 90s. And we mentioned the James Webb Space Telescope is like the state of the art. But these projects take so long, even from conception and design phase, and then to launch. There has to be a concerted effort to not adopt new technology, because you have to deal with technology that was implemented at the start. So 10-year-old technology that's implemented at the very beginning of these programs has to be able to talk and play with the new technology that's being applied at the end. So it's this paradox of aerospace and rockets is the most cutting edge and state of the art, but you have to walk this fine line where the old technology needs to talk with the new stuff, and it's got this timeline of technology on it.
Yes, because the duration of the projects are such that it can't be in different universes.
Yep. And I would think that what were the very first NASA missions? With
not Apollo?
With some of the Apollo missions, they probably started with slide rules and inserting cards into computers, and then possibly some of the end Apollo missions were probably pure digital computers and getting away from the card system. So that's
Goodness.
Yeah.
It's almost a slight indictment of the whole Moore's law thing, right? I mean, with technology ability and doubling and that, but I've never thought about the scope of projects and how you can't have things that aren't compatible. But now with, again, Moore's law and things evolving so rapidly, you just look at AI as a microcosm of just how it's not linear. Like, this growth is not linear by any stretch.
Yep.
Absolutely wild. So now we come as your senior account manager here now at Cintoo, correct? Is your position. So what have you learned from your clients, the wealth of wisdom you've accumulated in all your discussions, years of again, educating and persuading, and also just working, getting the boots dirty, as you put it. Whether about the industry, business, people, yourself, what have you learned from your array of clients in the space?
So, got into laser scanning, and they always tell you that it's the most accurate thing you can do. And we can get millimeter accuracy over hundreds of feet or hundreds of yards. And then 1 year later, guess what? Now we're down to 0.5 millimeter of accuracy and even over a greater distance. But then the more that I've stayed in the industry and the more that I've talked to clients, the words good enough keep coming up. And, we don't need 0.5 millimeter at 1,000 yards. We don't need tilt sensors, and we don't need levelness of, arc seconds and arc minutes. Once I really understood the industry and understood my clients, good enough really started entering, because that's kind of where the rubber meets the road and money starts to enter into the equation. So I spent maybe 2 years just trying to get the most accurate and be the most accurate and have the most accurate tool. But then these project managers be like, well, I kind of got this tape measure and it works good enough for what I need here. So this is why I believe mobile scanners have started to really make an impact in the industry, because what used to be laughable, here I am saying that 5 millimeters of error is laughable, but you can scan your airport now in half a day. I was doing 3 days by myself to scan an entire Walmart, when some of the new mobile scanners can get that done in half a day. And instead of just 1 millimeter of accuracy, 4 or 5 millimeters. So good enough is certainly what I've learned from my clients, and that's where the rubber meets the road.
Absolutely.
So it's kind of like taking a step back is how I want to say that.
As a company, from both a technological and business standpoint, what does Cintoo excel at?
From a technological standpoint, one of the best meshes in the game. And if you're not familiar with what a mesh is, I'll start to talk about the difference between a point cloud and a mesh.
Let's break it down.
A point cloud is made of points and individual points, and there's a billion of them. And if you're kind of far away from it, it looks like it's solid. But when you get close and you zoom in, it sure is just points with a lot of space between them. And there's a lot of power to that for computers and programming, because each point has an XYZ exact coordinate. But you could also imagine that the space between it causes problems for other things. A mesh is not the thing inside your swimsuit, but it is a solid surface connecting so it all starts with little triangles. And every time a point cloud makes a small little triangle with 3 points, software will create a solid triangle from those points, extrapolate that outward, and that's how you turn points with gaps in them into a solid surface. So one, the mesh is better to look at, obviously, because you can't see through it. But two, there's a lot of calculations and a lot of kind of measurements and stuff that, not measurements and calculations, but advanced simulations that need physical surfaces. It needs to touch something. It can't work with points. So converting a point cloud to a mesh, Cintoo is one of the best in the industry, and ultimately it makes the viewing of the point cloud much better. So one of the problems with sharing point clouds is if someone isn't familiar with a point cloud and you give them, let's say, a building of a point cloud that you can see through, someone is, they're literally looking through a building. They're seeing people in rooms that aren't there. They're seeing reflections from mirrors. So a mesh can take care of a lot of those issues. You can start sharing these point clouds with people who are unfamiliar with them, and you can expect them to have less viewing issues and less viewing problems because of that.
To the best of your knowledge, Cintoo's long-term vision?
So there's a bottleneck in laser scanning and all workflows where after you've scanned and processed and registered, you now have a point cloud, and they tend to be sizable. Anywhere from 100 gigs to I've created some that are terabytes in just a few days. How do you share terabytes of data quickly? A lot of the people in the industry, it was kind of a joke. They're like, so are you sending hard drives through the mail? Yeah, I'm kind of sending hard drives through the mail. Because we've all got these file sharing websites, but have you ever uploaded a terabyte successfully the first time?
Have a blast.
Yeah, it slows down everything. If you drop out for a second, it cuts. The same thing on the download. And then at a previous job, I kind of got my wrist slapped because I uploaded 500 gigs to the company's internal servers. I slowed down the offices in Atlanta and Fresno and Kansas City. The architects couldn't access their drawings because I was just uploading data. So Cintoo, we compress the data, we store it on the cloud, and we make it accessible. We have unlimited users, and with this compressed point cloud that's easier to manage and share, it's turned into a mesh so it's easier to view. And then we have unlimited users able to view it. It's about getting the word out. It's about distribution, and it's about taking care of the bottleneck after scanning.
Magnificent. So you've worked at length, laser scanning, point clouds, drones, data, largely in AEC for a decade. What's a development that has positively surprised you, and what's something you're surprised is not with us yet?
I'm going to get back to the drones and seeing their widespread use and their new applications and the new sensors. And I, log on to LinkedIn. I go, oh, all right, that's a new use for drones.
Yeah.
Oh, that looks great. So I love seeing the flying tripod get its glory.
Yep.
And what was the second question? It was,
what's something you're surprised is not with us yet, that we're not able to do yet, or we don't have yet?
So I've been scanning for 10 years, and I still get frustrated with either wirelessly transferring the scan or popping the SD card and the initial processing. I understand that it takes a lot of computer power and hard drives and chips, but I would love to see a manufacturer put a hard drive in the scanner, do all that initial processing as soon as it's finished, and then you can just either wirelessly transfer it or pop the SD card. And I want to see that initial processing done inside the scanner.
Tremendous. So we have the subjective cutter answer. I'm curious if the objective planetary size answer would differ. From your view, the next great leap in laser scanning is going to come hardware, software, or something we're not even thinking of yet?
I think it's going to be a combination hardware and software.
Okay.
I think it's going to be just right out of the sci-fi movies. We're going to have laser scanners on small drones. We can pop them out of our pockets. Laser scanners on drones the size of footballs, and then the software to process it instantly, make the file sizes manageable, and then that takes care of the sharing and distribution. So it's hardware and software, but it's always the smaller, better, faster kind of thing now. Mm-hmm.
What's the most, you mentioned hopping on LinkedIn and seeing random use cases. I mean, the most surprising, even off-label use of laser scanning or drones that's caught your eye?
Well, I haven't seen it on LinkedIn, but at Faro, the guy I replaced, he got a job in Los Angeles scanning models, human models, human female models.
Okay, wowzer.
But as far as drones, some of the defense drones, it's definitely not my cup of tea. but I can appreciate the technology and execution.
Yeah.
I'm seeing some of the speeds and some of the sensors and some of the some of the other powerful stuff that they put on there. So military applications, they tend to be the most extreme and tend to have the most backing, and that's why they tend to just be so awe-inspiring.
Absolutely.
Yep.
So models and military. Okay. Great.
Yep. Good old
Well, into
USA.
the spectrum.
USA.
Yeah. Cutter, what's a reality capture belief or practice embraced by many with which you disagree?
Good question.
Or call BS or
I opened myself up on LinkedIn maybe a week or two about this, and I'm expecting to get some explanations about it afterwards.
Yeah.
But when flying drones, I still don't understand the concept fully of control points and checkpoints. So when you fly, you've got control points, which are known survey points, and you use that in processing to make sure that the point cloud or the 2D mosaic image is accurate. And then you have checkpoints, which are known points that are not used in processing, but then afterwards you use them to verify the error of these random spots throughout your area. My misunderstanding is if why not use that as a control? So control points give you error and improve accuracy. Checkpoints only tell you error.
Mm-hmm.
Why would you not use the checkpoint as a control point to improve the accuracy further of the point cloud? So I got a long explanation of statistically biased points and how do you not know for certain. And the only thing in my mind is, theoretically, if I flew a drone over a strip of road and I had a control point at each end and a checkpoint in the middle, and the checkpoint tells me that I'm off by 6 inches, why wouldn't I use that checkpoint in the middle as a control point during processing to eliminate that 6 inches of error? So this is the concept that I'm not checkpoint versus control point.
Yeah.
Why I would use them all as control points to improve the accuracy of the orthomosaic and point cloud. That's how I understand it. Some surveyors and statisticians told me that there's a better way, but that's my lack of understanding now is checkpoints versus control points.
And any of those proponents, these surveyors, did they articulate on this now infamous LinkedIn post with, I'm just curious what the most robust argument counterpoint would be.
It was above my head. They were like they were paragraphs, and the one term that I can remember is statistically biased.
Statistically biased.
Because it was used in the processing, so it's like manipulated, but the control point versus checkpoint, I don't understand it. I'm 100% checkpoint, control point processor, and some people would choose not to use them.
And it has worked well for you, and you put yourself out there. And you made a statement. Good old LinkedIn.
Yep,
good on you.
Please, people, let me know. Find me. Explain to me. Send me some links and videos.
Get on the megaphone, folks. Let him know. Points for vulnerability, Cutter.
Yes.
Bravo. An issue we have not touched on. You, again, extensive background engineering, collegiate background engineering, right?
Yep.
Degree. On a scale of 1 to 10, 10 being an A+, how would you rate higher education as it pertains to AEC, construction tech, just innovation even on the whole? What was your experience there collegiately, and then just to whatever degree you monitor things now or are aware of developments and innovation, lack thereof, in institutions?
I couldn't put a number on it, because in my experience, I had two different experiences. I had a little bit of schooling. Well, I started at community college, which I'd advocate for everyone. But then I wanted to get into CU Boulder really badly. They wouldn't accept my transference for whatever reason. But a lot of my friends told me that their program is very... they do a lot of simulation work, a lot of experimental work. So these high-end computer simulations, which are critical for engineering, that's what a lot of my friends ended up doing at the University of Colorado. I got accepted to Colorado State, and I found that they had a very hands-on program, and they had what do I call this? A machine shop class where we even had a foundry where we melted ingots of aluminum and poured them, and it was more on the manufacturing side of engineering. So there are hands-on engineering courses and programs. There are simulation and computer and digital engineering colleges. So both are necessary for the industry. You've got to model it, you've got to test it and design it. That's the University of Colorado's route. But then you also have to build it, and you got to get your hands dirty, and you got to dig it, and sometimes you got to break it down. And that's the Colorado State side of education. So to put a number on 0 through 10, I couldn't say, but a lot of different universities are taking different paths to try and achieve goals and try and educate students on what they believe, because you got to train these students for what you believe the future will become. You kind of don't want to train them for today, because when they graduate, today is now the past kind of thing. So universities do their best to predict the future, educate for the future, and that kind of creates the future.
Well said. So correct me if I'm wrong. You would even take a slightly not optimistic in the sense that everyone is just sounding the AEC alarm. Like I'm thinking of Mike Rose and I know he's much more in the strictly sort of, wrench turning angle of things as opposed to tech and innovation. But there seems to be a real chasm between people that think, well, we're in this time of disruption and innovation and things are going to be fine, versus aging workforce, right? There's that issue. You have people coming out and that things could get dire. And I don't know if anyone truly knows what the future will hold in that regard. There's it's angle for AI and robotics and things. It's going to be one grand mystery, but it seems that you have a generally optimistic view of institutions instilling of education and passion and knowledge and different approaches, right? You're talking hands-on and things. So slightly optimistic in the sense that things from an AEC standpoint and
I haven't spent much brain power on it, but
yeah,
mostly optimistic.
Yeah.
We are seeing, that labor is decreasing, but everyone wants to be a manager and no one wants to be a laborer. But but you kind of need it's a complicated system. I see advancements in technology. I do see advancements in efficiency, but it's in my amateur opinion, it's a labor issue, and I don't even know where to start with that one.
Yeah. Coming back to your drone enthusiasm and just how there seems to be, at least anecdotally, my purview, that with youth especially, the allure to things that are cool and fun and can spur wow moments means something, I think, and that could be absolutely instrumental. And just a great scanner. And
if you walk that Boston Dynamics robot dog down in elementary school, every kid's gonna pay attention. And it's funny we're talking about this now. Anytime I was flying a drone around teenagers or kids, or they'd be walking by my project and see me take it off, they'd come over, ask about it. I'd tell them to please step back. I'll tell you all about it. And then I would always end with a stay in school, and then you can do cool stuff like this. I seriously, every time I talk to kids, every time they come up, it was half joke, half real, but stay in school, kids, because I get to drive robot dogs with an Xbox controller.
Using the kid lingo. Dope. Very dope. Your most frustrating professional failure or unsolvable puzzle?
Gotcha. Well, we talked about this for a moment when I walked in the office. It was summer of 2021, and I had to scan 1.6 million square feet of a of an office in Ontario, Canada. It was really a warehouse, not an office.
Goodness, I don't think you said 1.6 mil square. Okay.
Yep, 1.6 million square feet. It was 7 very large warehouses connected. We were driving trucks through it. I had a team of 4 or 5 people, and 2 or 3 of them were actively learning laser scanning for the first time on this project. So there was some shortcomings there. But the biggest shortcoming was me not knowing the deepest functions of the point cloud software that I needed to use. So it was 5 miserable weeks trying to process and register 1.6 million square feet. And I called on a certain Matthew Bird to be my Superman, and he helped me out. He spent another 5 or 6 weeks of his own time staying late in the office, helping me put together this point cloud. So, yep, he and I, we went to war together, and we can laugh about it now, but it was a huge scan project in Southern California.
Matthew Bird played the role of Savior.
Yes. Yep.
Get out of here. This modest guy. I haven't even heard of this tale before. He's been kicking himself. His heroics know no bound, I guess. Incredible. So off of that, that would be a singular learning experience. Any other, just not even necessarily from drastic failures, but just truly memorable learning experiences. Aerospace, AEC, drones, laser scanning, light bulb moments, aha moments, indelible lessons.
Man, I wish I had something to say right now because, like I said,
Take a minute. You can sift through.
Yeah, give me a minute here.
No, of course.
I talked about learning from my mistakes.
Yeah, think about it.
Love that.
Take a second, and I can even give a rephrase here. Take a beat.
Yeah.
So looking back at really a particularly diverse career, Cutter, from designing motors, gearboxes, spacecraft, to leading in reality capture. What has been another just pivotal learning experience? Not necessarily from a failure, but just a light bulb going off, an aha moment, a wow, just something that truly stuck.
Gotcha. So this is kind of human nature, and this is something that I had to experience going through sales cycles and talking with people.
Okay.
When you're selling something, you've got a product, and you're trying to help solve someone's problem.
Mm-hmm.
Well, sometimes when you're talking with a person, they're not going to tell you what their problem is. And even if you might think you get an issue out of them, or you think you might get what's bothering them, they'll tell you something. But understanding that the human nature, that sometimes people hide their problems, and it could be for personal reasons, it could be for professional reasons, they could be embarrassed, they might not want, for any amount of reasons, people withholding their needs when I'm here. People will withhold their needs. People won't express their problems, and I think that's just human nature, and I think that's humility, and that comes through in the sales cycle. And it was the first time that I realized that people won't share their true problems, and that might be like insecurity. It gets into psychology, and that was an aha moment once I went through that in a sales cycle and was able to peel back the layers. And I'd heard about it, and then once it happened to me, that was a big aha light bulb, a grok moment, if you will.
So if you'd be so kind, sales cycle. Elaborate for the non-sales folks. What?
Gotcha.
Please.
So it usually starts with, it can start with a cold call, me just reaching out, but the best ones usually start with a client who finds out about the product, and they call in, and I'd like to have some more information. So that's great. I'll give you a call. We make some time.
So it is just the personal. I just was, that I think most people know. I was making sure sales cycle was not referencing something on a more macro sort of seasonal
Oh, no.
no. So almost like sales workflow, as it were, right?
Yeah, sales
You'd
workflow.
almost like.
I was going to start talking you through my phone call here.
Oh yeah, okay.
Yes,
That's what. Okay, I wanted to make sure that wasn't
the sales
something.
The sales process.
Because especially with Farrell, like sales cycle, it's like, oh, is it something with product launches? Like, okay, got it, understood.
Is that a new laser
sales
scanner?
process? Yeah, absolutely. Okay, no, it's magnificent. But I want to narrow the spotlight on the psychological angle, actually, with this. And now, obviously, don't divulge anything that you should not.
Mm-hmm.
But was extraction of these guarded truths about these people something, whether it was someone whom you were shadowing, something you worked on yourself? I mean, what was that learning curve and that evolution of, or then even an ethical standpoint? Is there polite prying? Is there generosity that would welcome someone and encourage them to, or for him or her to share more? Or is it something just completely hands off? How did you go about, after that light bulb moment, working?
What I found that works best for me to get people to open up themselves is I start just oversharing the mistakes of my past.
Okay.
So if I can make myself vulnerable, if I can make myself the idiot, hey, look at all the mistakes that I've made, then it makes for a comfortable air, a comfortable space for people to open up and be like, okay, well, maybe we're actually really having trouble with my boss, or I'm actually really having trouble with the dump trucks, or whatever it may be. But it can sometimes come down and they feel it's a failure on themselves. But, people make mistakes every day. No one's perfect. So by opening myself up and sharing my mistakes and failures is how I get to these root causes and issues for others, or it helps to bring it out.
Door opening, in a sense.
Yeah, it shares my experience. It shares my, my knowledge, my experience, but also being open and, like I'm like you. Yeah.
Public speaking, be it sales, you mentioned a concrete, non-competitive competition.
Yeah.
I think, right?
Yeah.
Laser scanning. You still get nervous with it? Presentations and everything. Is it something you've also crafted and excelled at, both from a preparation standpoint and an execution standpoint? Is it something you enjoy?
I still get nervous. This was running through my head last night trying to go to sleep. But you better believe it was karaoke singing that was the breakthrough for me. And just karaoke at bars got me comfortable with the microphone, comfortable talking to people. But then I also remembered, if anyone had good parenting like I did, you're told to respect the person who's talking at the front. And once I realized all these things, I got used to like singing. I got used to like, oh, wait, when I'm sitting in a chair, I give my utmost respect to the person up front, and just realizing, empathizing with the people and practice. My gosh.
Yep.
Like I still get nervous, but you practice it, it becomes more normal.
Reps.
And it's a fun thing to do, especially getting done with it as well. It's like it's a weight off the shoulders, but it's also a way to kind of perform and play. So it's a lot of things, but karaoke singing for anyone out there, that was my big breakthrough. Yep.
Run up to the mic, folks. Nearest bar. Charles Kettering said, "If you have always done it that way, that is probably wrong. How have you challenged established practices in your field, and what resistance or opportunities did you encounter as a result?"
So I think this drone checkpoint and control
Yeah,
point
it sounds like you already started that fire.
We'll see. Hopefully some statisticians can get back to me on that one. But if the control point can make it better, why not use it?
Yeah. That's actually a great one. Yeah.
Other than that, I can remember I was one of the first sales engineers at Faro. They've got these settings. I can't even remember. It's resolution and quality. And again, this goes back to highest resolution, highest accuracy, highest quality. And I was one of the first engineers to be like, well, this is kind of good enough. I started stepping it back because of the whole time is money.
Yep.
And, a little stepping down the quality, stepping up the speed. That was, no one told me no, but I got a lot of interesting reactions. So
Yeah. Went a bit rogue.
Wasn't a mobile scanner, but I was trying to be faster.
Yeah. Cutter Shea, here in recap land, we like to have fun. And in taking this around to home plate, running the bases, some semi-rapid fire questions to get to know Cutter Shea and his expansive following on that beloved LinkedIn platform. Please, sir, the 3 best space movies and the most overrated.
Oh, my goodness. Okay. Aliens by James Cameron.
Now let's hone in on it, not the second, because if you're saying aliens.
And this is plural. Yep.
Okay.
James Cameron.
Solid.
This is coming to me, though, but I believe it's called Space Quest with Tim Allen. It's entirely funny, but entirely serious at the same time.
I think it's Galaxy Quest.
Galaxy Quest.
Galaxy
really,
Quest.
Really awesome. And another recent sci-fi film that's...
There's good recent sci-fi.
And those are the 2 that I just love right now.
Aliens over... I want to hear...
Oh, yeah, it's the best.
My
brother
not
and I
even
could
no
quote
contest.
that one forever.
Yeah. Oh, it's superb. The original and just that damn chest explosion of the original. It's just talk about seared into memory. But Aliens is great. I did not know. Okay, so Ridley, I think Ridley Scott did the first one. I did not know.
Ridley Scott was more of a producer.
Did he not do the first Alien?
I don't think he was director.
I'll be damned.
He's very much like the creative guy.
Okay.
He's the one who had the vision and the drawings and like the story, but I don't think he was director. He's involved in every one of them, but it's like he's more production.
Of all your lessons today, and if it holds that James Cameron did the first 2, wow.
No.
Okay.
James Cameron only did second one.
Okay.
But,
magnificent.
Yeah. Yep.
Well, boy, did he crank out some great sequels then in that era, because with Terminator 2 for Jim, along with Aliens to step in, magnificent. And Galaxy Quest. Okay. Favorite drone moment?
Let me think here. Okay. Well, one that's kind of making me laugh is real small moment, but would you believe it? I crashed my drone one time.
Ouch.
Little ouch. But it was kind of funny. Windy day. I was absolutely at the maximum of the allowable wind. And it's really cute because it was at the very start of the flight. I hit go. A wind gust came up, and the drone literally flew 2 or 3 inches up, flipped 180, and then landed right back down. It couldn't have been a lower elevation crash. I'm in the parking lot like, did anybody see this? Flipped it back over. Nothing was wrong. Had a full laugh about like the best case scenario crash.
Yeah.
And then like, all right, let's complete this mission in 30 miles an hour wind. And this was one of the original DJI, the original drone. I forget what the classic white one.
Okay.
So it's the workhorse that everyone's used. It's 10 years old.
Yeah.
Flipped over, propellers popped off, and then completed the mission. So I'm very proud of that DJI drone. Yep.
Best thing to eat in Denver, Colorado?
Oh my gosh.
For those who may be visiting,
Yeah. Well, the classic one is the Buckhorn Exchange. It's the very first liquor license ever given out in Colorado.
Oh, no kidding.
It's covered wall to wall in taxidermy, and you can get like a 2-pound steak and some whiskeys. But I'm a big fan of, let's see here, it's called Hops and Pie, and they kind of make some designer pizzas. The first time I ever had duck was on one of their pizzas. So I gave you the classic Denver, and I also gave you a little bit of new Denver.
Yeah, very much experimental. Duck on pizza. I love it. Most memorable vacation activity?
Well, there was this one trip I took to Croatia, and Dubrovnik was one of the stops. And I'm walking around this old walled city by myself, enjoying a hot summer afternoon. And on this one portion of the wall, there's this little kind of metal grate, like a prison door. And from the outside, 2 kind of tourists kind of open it, pop their heads, walk through it. And I go, oh, is that a little hole in the wall that I should check out? So I go out the hole in the wall out the back of Dubrovnik, walk down some steps. There's a bar on the cliffs overlooking the ocean, and then down one other set of steps is just the perfect platform for some cliff diving.
Oh.
So I saw some Aussie dudes doing it. I jumped in from about 30 or 40 feet,
Yeah.
then got a beer at the bar. And this is all in Dubrovnik, which was one of the main spots filmed for Game of Thrones. So it's a lot of Game of Thrones stuff and this ancient walled city. And I found the hole in the wall bar to do some cliff diving. That was a fun one. That's a fun one.
Pure bliss. Croatia.
Mm-hmm.
Memory serves, I think that was one place of Anthony Bourdain's many, many, many travels that really had him questioning, why the hell don't more people know about this place? And like, why do, I mean, there were tourist spots. Dubrovnik, I think there's another, oh goodness, I think it starts with an S. Split, Croatia.
Yeah.
Thank you. Well done. Yeah. I mean, there are huge cities there, huge soccer following, but it's like a place that you talk to anyone that's been there and it's endless raving, so that makes sense. Go to the last question. Might you have any theories on last fall's near endless drone sightings in many places, and particularly New Jersey? Yes, this might get into aliens. That is okay.
Yeah, I've got some insights.
What?
Not every single, most of those videos of these mysterious vehicles
Yes.
all had the FAA approved red and green lights on them, mysteriously. They were all just drones, probably some larger ones. And, people get excited about things that they don't know. Not aliens. They were all kind of FAA approved drones. And anyone who saw those green and blue lights knew that it was like a normal manufactured drone. They might be big. They were running some official missions. I don't know the companies or what the projects were, but they were running flights over airports. So some of the airport closings, I believe, were like expected. And then some of the other spottings were just like regular private jets just at night. So it was a lot of hysteria over
Okay, so
stuff.
what?
Yeah, the
much
average
ado
person
about-
seeing something in the sky.
So largely much ado about nothing, but you're still, it was at least an orchestrated, if I'm hearing you right, governmental, recreation, people were...
Yeah, not recreational because, probably not
commercial?
recreational, but either commercial or industrial, but these are all, if the drones had those red and green lights, that means you can commercially buy them and they're available to the public. And it just was a silly summer hysteria for me.
If it was for commercial purposes, wouldn't someone come out and, yes, this is us, or we're with such and such corporation and we're why no announcement?
This is why we'll talk about this next summer.
Who are you carrying water for, Cutter? No,
DARPA.
Plenty fair answer. Cutter Shea, man of many talents, and who I think we mentioned that Bennu, the asteroid, is, as we speak, still delivering mind-blowing results to analysts that may contain clues to our universe and the origins of life. You've had your hands in many successes and still do daily now in reality capture from your ventures in aerospace. We thank you for them and for coming to the Recap Podcast. It's been a real pleasure.
Ellis, thank you so much. It's been an honor, and I'm just so happy to share my story. Thank you.
Great stuff, Cutter. Be well.